Hi everyone. In my today's session, I'm going to explain about one more behavioral design pattern called observer. Okay, observer or observable basically. Okay. This pattern states that an object named the subject maintains a list of its dependents, okay, called observers or subscribers, and notifies them automatically of any state changes, usually by calling one of their methods, and where the state change happens in the subject. Okay, so in my previous video, I had already explained the .NET events and delegates. Okay, so basically your event is a construct in the .NET available which internally implements observer design pattern. Okay, guys. So your event is basically a observer design pattern. Okay, so it is often used for implementing distributed event handling systems in event-driven software. In such systems, the subject is usually named a stream of events, okay? The subject, okay, or the observable, I can say, okay? In such system, the subject or the observable to whom we observe, okay, is usually named a stream of events or stream source of events because subjects is the one who basically produce the events, while the observers are called sink of events, okay? So why they are called sync of events? Whatever events come from your source, they will basically subscribe or hold those events. Okay, they will they will get those events from the subjects basically. The stream nomenclature alludes to a physical setup in which the observers are physically separated and have no control over the emitted events from the subject or stream source. Okay, so the subject and the observers, okay, these both are loosely coupled. Okay, they are not tightly coupled together. Okay, so that's why the observers or the subscribers basically, they don't have any control over the subject on what basis the subject will basically create events or notifies a lot of events. Okay, so whenever event comes, the observer or the subscriber has to just listen to that event and take appropriate actions from their side. So this promotes a loose coupling in order to implement this kind of notification to your subscriber objects. This pattern thus suits any process by which data arrives from some input that is not available to the CPU at the startup. Okay, mark this statement, guys. This pattern thus suits any process by which data arrives from some input that is not available to the CPU at the startup, but instead arrives seemingly at a random period of time. Okay, so the http requests we do, okay, which are basically we don't know when we receive the response, we do the request and we wait, we basically listen to the response, and when response comes we take some actions. Okay, same like your peripheral devices, distributed databases, blockchains. Okay, so all these are some examples. Which problems can the observer design pattern solve? Okay, a one-to-many dependency between objects should be defined without making the objects tightly coupled. Okay, so you have to establish a one-to-many dependency or relationship between the objects, okay, without tightly coupled, without making them tightly coupled. Okay, there should be a loose coupling. So this is the problem what observer is going to solve. And also when one object changes the state, an open-ended number of dependent objects should be updated automatically. Okay, when one object, in this case the subject, whenever the subject state changes, all the dependents or the observers or the subscribers who are interested in that subject's state change, okay, should be automatically updated. Okay, an object can notify multiple other objects. Okay, so these are the problems which the pattern is going to solve. Okay, so what are the solutions this observer design pattern gives? Define subject and observer objects or interfaces, I would say. So you define a subject and observer interfaces or objects. When a subject changes the state, all registered observers are notified and updated automatically and probably asynchronously. So the .NET events, the C sharp events and delegates have the capability to automatically updated about a notification sent from their subject asynchronously using the threads. Okay, so that is also available in C sharp programming language. Okay, So usually a subject maintains a list of observers. Okay, soon I'm going to show you that implementation. So whenever some change happens, it will simply iterate over each and every observer and call their update method. Okay, to notify that some change has happened in the subject state or the source of event, you could say. Okay, the source object. Okay, the sole responsibility of a subject is to maintain a list of observers and to notify them of the state changes by calling their update operation. Okay, the responsibility of observers is to register and unregister themselves with the subject, the way how we registered our handlers and unregistered handlers to a .NET event. Okay, in order to be notified of state changes and to update their state, to synchronize their state with the subject state when they are notified. This makes subject and observers loosely coupled. Subjects and observers have no explicit knowledge of each other. Observers can be added and removed independently at runtime. Okay, understand this. There is no dependency, there is no hard coded references. They can be added, removed independently at runtime. This notification registration interaction is also known as publish subscribe model of events. Okay, one problem may arrive, which is a strong versus weak reference. The observer pattern can cause memory leaks, okay, known as a lapsed listener problem. Okay, so because in a basic implementation it requires both explicit registration and explicit re-registration of your observers or the handlers, I would say. I think I had already explained this in the events and delegates tutorial, guys. Okay, it's our responsibility to unregister your handler in your dispose method of your class. So whenever you are done with your operation, right, the class which makes use of the event handlers, okay, or the event class which is basically registering a n number of handlers, right, it should implement a I disposable interface, and in the dispose method it should basically unregister from all these events, or the observer itself should take the responsibility of unregistering themselves by implementing the I disposable interface in C sharp.net. Okay, there are two ways, but the second is the most preferable approach. So as I said, it requires both explicit registration and explicit deregistration, as in the dispose pattern. Okay, because the subjects hold strong reference to observers. Soon I'm going to show that. Okay, keeping them alive. Okay, this can be prevented if the subject holds weak references to the observers. Instead of holding a strong reference, we can hold a weak reference to the object. What is the advantage of weak references? Okay, as a class available in the .NET called weak reference. So weak referenced objects, okay, doesn't block the garbage collection process. Okay, so if you want your garbage collection to happen over your program still having some object references, okay, for example, you have some object which is very difficult to create and takes a lot of time to construct it, okay, from the computational side, from the creation side, such objects you can make a weak reference. So what is the advantage when you make it a weak reference, right? It will not block the garbage collection process. When it sees the object is weak referenced, okay, it will not be considered for the garbage collection. It will keep it as it is in the memory. It will perform the garbage collection, and whenever you want a reference to that object, right, you have to once again call its target method in C sharp on the weak reference object to get reference to that object which you made it at a weak. Oh, okay, which you made it as a weak reference. Okay, by referencing that target you once again get a hard reference to that object. Okay, so that's just a small intro to weak references and strong references and the UML class diagram. Okay, look, I have an interface I observer or observer abstract base class, and then I subject for the subject, and subject maintains a collection of observers, a list of observers basically. Okay, see the aggregation here. Okay, this is a aggregate which contains observers. Okay, and then you have the standard methods: register a observer by passing a observer object, unregister a observer. So register observer is just adding an observer to this observer collection. Okay. List basically list dot add. Okay. And then removing observer, list dot remove that observer. And then the most important method is notify observers. Whenever this method is called, see the UML diagram, notify observers when called for observer in observer collection, call the observers update method. That's it. Okay, you are updating about a state change in your subject, and that notification will go to all the observers update method. And you can optionally pass some data also about the state change which can be used by your observers. Okay, so observer, which is a interface, and you should have a concrete observers like this, which provide a implementation for your interface. So now let's go through the program and understand. So I have written a small program which basically depict a online mobile buying scenario. So for example, you would have seen the OnePlus mobiles, okay, the iPhones, okay, Micromax, all these kind of mobile phones, right? They won't be available at any instant of time, okay? Whenever such mobile phones stock is available, okay, so what the basically the vendor subscribes an event, okay, the vendor basically sends a notification to all its subscribers that, boss, this particular phone is available for this particular window, okay, hurry up and buy the phone. Okay, so this is how they basically notify all its subscribers. So I'm going to show you that. So let's go with our UML diagram. First of all, I should create a observer contract, which is public interface I observer, okay, or the subscriber you can call. Okay, so what this observer or subscriber contains, it contains one method which is void update. Okay, so what this update is receiving, it is receiving the mobile phone availability and then the mobile phone name. Okay, so the I observer or observer is a subscriber, okay, one who listens to the notifications or events. Then comes subject, who produces the events. Okay, once again, public interface I subject, register a observer I observer, remove a observer I observer, and then notify observers as per our UML diagram. Okay, let's go through the concrete implementation of the subject, public class subject, which implements I subject. Now see, it basically maintains a strong references to observers. Okay, our private list of I observer observers. Okay, so what happens if you provide a key observation, it is implementing the I subject interface. And if you see the interface methods over here, register a observer, you pass a I observer object. Okay, and what are you doing? You are simply adding that incoming observer to this observer list over here, observers. Okay, remove observer, you are removing from the observer. Notify observers, what are you doing? Okay, for each observer, whenever the state changes, okay, let me go through the state. So what is my subject's state here? Product name, product price, and the most important thing, its availability. Okay, so based on this particular member of my subject, this particular state, okay, my observers will be notified. Okay, so when it is available, they will be notified that it is available. When it is not available, again an event will be sent, a notification will be sent, and the observers will be notified that the product is not available. So how that event will be fired? Okay, let's go through it. Okay, so get availability, a simple method which returns the availability, whether it is available or not. Okay, then comes the most important method, is set availability. Okay, so whenever you set a state of your product, whether it is available or not, see what happens. Okay, this dot availability code, you are setting the availability, and you are saying that availability changed from out of stock to available for product name. Okay, so basically what happens is, in the initial state it is not available, it was out of stock. This is just a trivial program. Okay, you can change the state from available to out of stock, from out of stock to available. Okay, so what happens is, when for the first time the program loads, okay, there are no available, okay, the stock is not available for my phone. Okay, so that is the initial state. But when the availability happens, when the stock is available, basically you are printing availability changed from out of stack to available for the product name, and then you call the notify observers method. This is the most important thing. You should always fire the notify observers method from your set availability only. Okay, whenever the state changes of your availability state. And this method, what it is doing, it will iterate over each and every observer available in your observer or subscribers, and then update each, and calls the update method available on each observer, because iObserver has only one method, which is update. Okay, and you have a list of observers available, so iterate over them, call the update method. This way you are basically notifying your subscribers or observers that something happened with your subject's state. The state is availability here. Okay, and as usual, the observer implementation, you can add a subscriber, remove a subscriber. Okay, and yes, you can implement the update method. Okay, so when you call this update method, then the concrete observer which is implementing iObserver will provide an implementation for update, and he can update his state or her state inside his class as per his requirement based on the event or the notification received. Okay, so let's run this program. See, I will show you the setup what I have done. My subject is iPhone 14. Okay, a mobile product, basically mobile company. Okay, so subject iPhone 14 equal to new subject Apple iPhone 14. Price is this. Currently it is out of stock. Now I will create my subscribers or observers basically. So see, observer. I'm creating a subscriber one G2, and then I'm adding to what I'm doing. Yeah, I'm basically adding the subscriber now. Yeah, so what I'm doing, subscriber one dot add subscriber, I am passing my subject. Okay, who is subject? The mobile company. So this internally what happens is, if you see the call, go to implementation. Okay, what are you doing? Whatever subject object you are receiving, on that subject dot register observer of this. Can you see? This is the concrete class implementation I provided. Like this, you may be having a n number of observers, concrete observers basically. Okay, so in my case I created only one observer, but you can have different implementation for your observers. Okay, so in my case the observer is a end user. Okay, there will be a business to business scenario. Okay, like some shopping malls and all. In that case you can create a observer like shopping mall observer. Okay, a store keep unit observer. Okay, a shopping mall observer or a store observer. Like that you can create a hell lot of observer objects, and there what you need to do, subject dot register observer, just pass the this reference and it will automatically add that observer to the subjects observer collection over here through this method. Okay, so what I'm doing, subscriber one dot add subscriber, passing the subject like that. One more subscriber I'm adding, Giri, and then one more subscriber, Ahilya. Okay, and then I'm getting the current state, and then I'm removing an subscriber, and then I'm setting the availability to available. So if I run this program, see, observer or subscriber added. So three subscribers were added, G2 Giri Ahilya. Current state of iPhone 14 is out of stock. So one subscriber, Ahilya, unsubscribed herself from this subscription. And then availability, I changed the availability, the company changed subject basically. Okay, the iPhone company or iPhone provider changed the availability from out of stock to available for the Apple iPhone 14. Okay, now what it is doing, notifying all subscribers the product Apple iPhone 14 with price 1 lakh is now available. So see, hello Jitu. Now the each and every subscriber received a notification, and what my subscriber is doing basically, it is saying the product phone. It is receiving a message from the subject that hello Jitu, product Apple iPhone 14 is now available on Flipkart. Hurry up. So what he will do, my subscriber Jitu, he will go and buy that phone. Same, Giri will also receive the message like this, the product Apple iPhone 14 is available. So it's up to him whether he want to buy or he want to just ignore that message. Okay, so this is how the observer design pattern is implemented. I hope you people understood the notion of this pattern. Thank you for listening. Have a nice